So, what is the square root symbol called?
A radical.
A radical. What is the little number called? The little number is the index. If there's not an index, what is it? 2. And what's the number under the radical called? Radicand. Good. So let's talk. Let's do some problems. Okay, the square root of 121 is what? 11. Did you just know that?
Yes.
In your brain?
Yes.
Great. So let's make a mental note, okay? A work in progress for you, okay? This is something I need you to have accomplished by the end of the year, okay? Work in progress. You should have all of your perfect squares memorized up to 20. What is 20 squared? 400. So that means the square root of 400 is? 20. Good. Okay, so our work in progress, friends, our work in progress is to have memorized up to what number? 20 squared or 400 square root, okay? Now, what about number 2? Number 2, is it a square root?
No.
It's a cubed root. Cubed root of 125 is what?
5.
Good, 5. So once again, another work in progress is having your perfect cubes memorized up to 10 cubed. So that means having 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and 10 cubed in your brain. By the end of the year. Not right now. Okay? Now, for your quiz, for your test, anything you see on the notes or the homework is fair game for having memorized.
Oh my gosh.
Okay? So, if I put the cubed root of 125 on your test, it's on your notes. You should know it. Okay? Do we understand? All right. What about the cubed root of 27?
9.
Nah.
3.
3. So when we're thinking, oh, I did. Look at that. Sabotage. Listen. So when we're thinking of cube roots, we're thinking what times what times what? Yeah? So 3 times 3 is 9, and 9 times 3 is 27. So that's where we're getting that from, yes? What about the square root of 144? 12, good.
13.
Good. Square root of 169 is 13. What about the cubed root? Ooh, good. 4. So once again, what times what times what? 4 times 4 is 16. 16 times 4 is 64. Yeah? So can I fairly ask any of these questions on the test? Yes. What about anything that's on your homework?
Sir, yes, sir.
Yes. Good. Next, we're going to talk about simplifying radicals. Simplifying a radical is taking the number that's inside the radical and trying to make it smaller. We try to make it smaller by kicking numbers out of the radical to the front. Okay? Do we understand that explanation of what we're doing? So if I'm starting with a 20, I want a smaller number in the radical when I'm done. Yes? There's a couple different ways to think about simplifying radicals. I have one way that I prefer, but there is another way. So you could have learned it with prime factorization. That's probably the one that you've learned the most. Okay? But there's another way. So I'm going to kind of jump back and forth between the two and show you both to see which one you think is easier. The more perfect squares you have memorized, my way, the more advanced way, will be easier. Okay, but if you don't have a lot of perfect squares memorized, then it'll be more difficult. So for 20, let's do prime factorization. Do y'all remember what prime factorization is? Yeah, we're taking a number and breaking it apart until it gets to prime numbers. Okay, so if I'm going to break up 20, what am I breaking it up into?
2 and 10.
Okay, for the sake of this, let's do 2 and 10 because we're going to do 5 and 4 here in a minute. Okay, 2 and 10. Is 2 a prime number?
Yeah.
Yes? What about 10?
No.
Okay, break it up again.
5, 2.
Good. Okay, now with prime factorization, how this works is since this is a square root, we're looking for pairs. Okay, if it was a cubed root, we'd be looking for sets of 3. Do you remember? Does that difference make sense? Yeah? Okay. Do you see a pair?
Yes.
2 and 2. Okay? I have a pair of 2s. That means the 2 gets to leave the square root. But I don't have a pair of 5s, so the 5 has to stay. Okay? So 5 and 4, there's actually a quicker way to use it if we do 5 and 4. And this is like the Miss Adams way. This is my way. I don't mind prime factorization, but it's not my favorite. Okay? The way I think of simplifying a radical is I think of what perfect squares is my number divisible by. Okay? So list of perfect squares. We have 1. We have 4. We have 16. We have, yeah, exactly. So those numbers. Okay? What perfect square is my number divisible by? 20 is divisible by 4. Okay, so I can break this up into the square root of 4 and the square root of 5. Because 4 times 5 is 20, right? Would you agree?
Yeah.
Are we following?
Yeah.
What is the square root of 4? 2. So that means it gets to leave. I can't take the square root of 5, so it stays. So that's how I do it. I don't do it with prime factorization. I do it with perfect squares. For these notes, I'm going to kind of show both, and then you can pick your favorite. You can change it up on each problem. Doesn't matter to me, okay? So if I'm looking at 300, okay, let's do it with prime factorization. I think of 30 and 10.
Can I still do 3 and 100?
Perfect. You totally can. Have at it. Yep. Have at it. Okay. 30 and 10. What does 30 break up into?
6 and 5.
Okay. 6 and 5.
And then 3 and 3.
3 and 2. Good. Shh. What about 10? What does that break up into?
5 and 2.
5 and 2. Okay. Looking for pairs.
5 and 5 and 2.
5 and 5 and 2 and 2. So that means a 2 gets to leave and a 5 gets to leave, creating a what?
10.
A 10. And what has to stay?
2.
The 3. Good. No, you're good. Okay? Now. Yeah? Now, if I had done instead the Miss Adams way, which is what perfect square is 300 divisible by? 100. So I have the square root of 100 times the square root of 3. The square root of 100 is 10. So it's 10 square root 3. Okay, that's how I do it. I think it's faster. Now, prime factorization might be easier if you don't see a perfect square right off the beginning. Yes? Okay, so what did you break 30 up into?
3 and 10.
3 and 10, okay.
I just put an X.
3 and 10. And then what does 10 break up into?
5 and 5, but you can't get it. But there's
No pairs. No pairs. Is 30 divisible by a perfect square? No. So I cannot simplify it. Square root of 30 is the easiest as I can get. That's the lowest I can get. Okay? I can't bring anything out. Does that make sense? Yeah? Or just, yeah. I just circled it, but yeah. Yeah. What about number 10? Is 25 a perfect square?
Yes.
What is it? Square root. Okay. And then is x squared a perfect square? What is square root? X. 5x. Please don't miss that problem. Number 11, we have a number, an x, and a y all under the radical. Some different options you don't have to use. I sometimes like to separate them so that I have the number in a radical, the x in a radical, and the y in a radical, just so I can look at them one at a time. Okay, so that is an option for you. You can do that. Okay, these are all being multiplied together. So if I'm looking at the square root of 40, is 40 divisible by a perfect square?
Yes.
Yes. What perfect square?
4.
4. Okay, so I can break 40 up into the square root of 4 times the square root of what? 10. The square root of 4 is 2. So would it be 2 square root 10 simplified?
No.
Yes.
Yes.
Oh, yeah, I thought you had to bring in the X and the Y.
Well, we're not done yet. Yeah, so we're done with just the 40.
Oh,
Okay, just the 40. Okay, x squared. If you get confused with letters, you can always expand them out. So x squared is just 2 x's, right? So I really have the square root of x, and then at that point we're looking for pairs. So I have 1 pair of x's, which means that an x gets to leave the radical, there's nothing left. Versus with the y's, I have 1, 2, 3, 4, 5 y's.
Like 6 or 7.
So 1 pair, 2 pairs. So 2 get to leave the radical, 1 has to stay. Yeah? 1 pair, 2 pair, 2 leave the radical, 1 has to stay. And then we put it all together. So we have a 2 outside my radical, an x outside my radical, and a y squared outside my radical. Inside my radical, I have a 10 and a y. Okay, try number 12. Ready, set, go. Okay, so our last section is radical operations. That's adding, subtracting, multiplying, and dividing with radicals. When we are adding or subtracting radicals, the radical has to be matching exactly, okay? So the number outside the radical can be different, but the actual radicals have to match. So do you see on number 13, I have a square root 2, a square root 2, and a square root 2? So I can add those because they have matching radicals. I can add the 5, the 3, and the 1. So it's kind of like combining like terms with x's and y's. Your radical is now a variable. Okay, so you just add the numbers in front. So I have 5 plus 3, which is 8, plus 1 is 9, and then the square root 2 just comes along for the ride.
Just add them so we wouldn't add the radical.
Right. It just stays the same. Okay. Now with number 14, I have a square root 5 and a square root 7. Can those be simplified in any way? No. Do they match? No. So can I combine them? No. Can't combine.
Wait, Miss Adam.
Yep.
So it doesn't matter about the index, or not the index, the number outside the radical.
Right. It's just.
It matters about the
Yep.
number inside the radical.
Yep. The index would also have to be the same. So if I had like a square root 2 and a cube root 2, I couldn't combine
Okay,
those.
so the outside number doesn't matter. It's only the
Right, exactly. But once they match, the outside number is what I'm adding.
Okay.
Yeah. Okay? So let's look at this one. Not the same, right?
No.
But can they be simplified?
Yes.
Yes, okay. So let's take this 4 or this 8 and we're going to simplify it. Now, what is 8 divisible by that's perfect? 4. What's the square root of 4? 2. So I'm going to rewrite square root 8 as 2 square root 2. Was that too much? Okay, 18. What perfect square is 18 divisible by? 9. 9 times what? 2. Okay, writing square root of 18 as 3 square root 2. Was that too much?
No.
How did I get the 3?
I don't
The
know.
9, because 9 is perfect.
9 is perfect. The square root of 9 is 3. So in order for that 9 to leave the radical, we have to take the square root of it.
Wait, pause.
Okay. It'd be like this. There we go.
Okay. I'm just going to
Eh?
Yeah.
Are we following with the 18?
Yes.
I kind of showed my work off to the side there. I was doing some brain work. Okay? Okay, I bring down my plus sign. Do I now have matching radicals? So can I add these? Yes, and I get what? 5 square root 2.
Then it has match.
When we're multiplying and dividing radicals, the radical doesn't have to match, okay? It has to both be square roots or both be cubed roots or anything like that. But the numbers underneath don't matter, okay? We don't have to make them matching. We can just multiply, okay? So if I'm looking at number 17, I see square root 10 times square root 15, which if I multiply 10 and 15, I get what?
150.
Good. So it's the same as the square root of 150. Okay?
Wait, hold on.
That's okay. Hey, Jacob, put all the fidgets down. All of them. Thank you.
So on the test, is it asked like this? Do we just give the answer of like square root 150, or do we have to like
No.
find
So now we have to keep going because 150 can be simplified.
Oh, okay.
Okay?
Wait, 25 and 5, right?
25 and 5. I'm going to go a different direction because I picked something else. But 25 and 5 is fine. Oh, not 25 and 5. 25 and 6? I don't know. Anyways, I did 15 and 10. Okay, I did 15 and 10. I wasn't 100% sure on my perfect square, so I just picked 15 and 10, and I'm going to do prime factorization with it. Okay, so 15 can get broken up into what? 5 and 3. And then 10 can get broken up into what? 5 and 2. Do I have any pairs?
Yes.
I have a pair of 5s, right?
Yes.
Okay, so that means a 5 gets to leave. Did I have a pair of 3s? Did I have a pair of 2s?
Nope.
So they couldn't leave. So inside the radical, I still had a 3 and a 2 multiplied together to make what?
25.
A 3 and a 2 multiplied together to get 6. Good.
Add 5 circles.
Just 6. Just 6. Let's do it again with letters, okay? So we're going to multiply first. Are we focused?
Yes, ma'am.
Are our eyes on the board?
Yes, ma'am.
I don't see everyone's eyes on the board. I don't see everyone's eyes on the board. Thank you. Okay, so I'm going to multiply first. So 6 times 3, 18, right?
Yes, ma'am.
X cubed times x to the first is x to the what? 4. Is that better?
Oh, yeah, thank you.
Okay, y squared times y to the 5th is y to the 7th. Good, so remember our exponent rules as we're multiplying. Okay, so now I'm here, right? Okay, let's go with perfect squares. Mm-hmm.
Oh, wait. 9 and 2.
4.
Yeah.
Wait,
Yeah, good. 9 and 2. 9 times 2 is 18. Okay, what's the square root of 9? 3. So 18 is going to become 3 square root 2. What was the 3 before it left? A 9. Okay, so it was a 9 times a 2. Square root of 9 is 3, so the 3 left. Yes? Okay. X to the 4th. That's 1, 2, 3, 4 x's. How many pairs?
2.
2 pairs. Any left over?
No, ma'am.
Good. So an x squared leaves, right?
Yes. Wait, no, wait.
Yeah.
Oh, you
Yep.
said leaves.
Leaves.
Oh,
Leaves. Okay. And then the y's. I've got 1, 2, 3, 4, 5, 6, 7.
3 pairs and 1 stays in.
Good. 1, 2, 3 pairs. So a y cubed.
1 y.
And there's 1 y left inside. Let me write that a little nicer. So we have 3x squared y cubed square root 2y. Number 19 is division. Same thing. They don't have to match. Now here's the deal with these. Divide first. Okay? Divide first before you start trying to simplify. Because it'll make it a lot easier. So I'm going to divide. 8 divided by 2 is what? 4. Okay? X to the 5th divided by x squared. What exponent rule is that? x3, good. We subtract, so x cubed. Okay, now I can simplify with this rather than the fraction. Yeah? Okay, what's the square root of 4?
2.
Does it get to leave?
Yes.
Okay.
Bye-bye.
How many x's get to leave?
1. 2.
2x, one pair. Good, one pair. And is there anything left in the radical?
Yes.
1x, good. So one pair leaves, 1x is left. Yes? So since it's only one pair leaving and it's an x to the first power.
Yep. Yes, ma'am.
Yes?
Yes.
Huh? Killing it. I don't know, maybe. Okay, dividing first. Dividing first. Okay, 8 divided by 2 is what? 4. Cubed and squared gives me what? Just an x. Does this guy have anything to divide with?
No.
Does he get to then leave the fraction?
No.
No. So he's actually still just hanging out down here. Hanging out. Chillaxing. In the bottom. Yikes. Spooky. Spooky. Okay? Now at this point, I'm having a hard time visualizing. So what I'm going to do, okay, what Miss Adams is going to do, Jacob, is that Miss Adams is going to break the top and the bottom into their own radicals. Totally allowed. Okay? Top and bottom in their own radicals. What's the square root of 4? 2. 2, so it can leave. Does that x get to leave?
No.
No, there's only 1, right? So it's going to stay. Yeah? Okay?
Yes.
If I have 6 y's, how many leave? 3 pairs leave. Are there any pairs left?
No.
No.
So if this happens,